So we've been asked to find points of inflection given a function. And so in graphical sense, we've been given a function and we need to find the point of inflection here in blue. Well, that's going to line up with the second derivative equaling 0 and changing sign. So that means we need to find the second derivative. Well, f prime would then be 30 x to the fifth minus 15x to the fourth, and f double prime would equal 150 x to the fourth minus 60 x cubed. I can see that there's a 15 in both and an x cubed in both, so I'm going to factor out 15x cubed, and what I'm left with is x minus 4, scratch that, 15x taken out leaves me a 10x minus 4. Now as I look at this, I could have also taken an extra 2 out and made this 30x cubed and 5x minus 2. Wouldn't have mattered. Either way, you'll get the same answer. Our zeros are 0 and 2/5. Because we're looking for a second derivative, we really don't care what this graph looks like, we care if it bounces or crosses. And we can tell by looking at this second derivative that we're going to cross at an odd multiplicity and cross at an odd multiplicity. So our answers are going to be 0 and 2/5. So let's practice graphing this second derivative, because if we were given a first derivative, we'd need to know whether we are what it looks like. So this is fourth degree, and it's positive, so I'm going to go up and up. I know that I cross at 0, and I cross at 2/5, and so I can come down and just draw this fourth degree function. That's a simple enough sketch of our second derivative. And again, we crossed at 2/5 and 0, so those are our points of inflection.